Hi guys. All right, we are starting a new lesson. We are starting lesson 20. So this is lesson 20, session 1. If you see the shadow over here, that's a cattail. Ollie is trying to do our math lesson with us, I guess, so he might interrupt. This is the family letter for this lesson, so it's on page 411. If you want to read through this with your family, let them know what you're working on this week for math. And on the back of this one is actually kind of cool. Usually they have like an activity or a problem to do with your family. This one is really neat. So, excuse me, Ollie. This one has a recipe because, you know, we're working with fractions, so fractions are pretty prevalent in recipes. So it actually has a recipe for like a dip spread stuff, like, you know, like you dip crackers or chips or veggies in this case in it. So there's a recipe that you can follow and it tells you how to make it. So that would be kind of fun to do with your family if you have that kind of stuff at home, cream cheese and sour cream and herbs, just says herbs, whatever kind you have, I guess. And then there's just a couple questions at the bottom about the recipe, like the fractions in the recipe. So pretty cool. If you want to do that with your family, tear out this page and do that. That would be awesome. Okay, so lesson 20, session 1, and this page is 413. Okay, so kind of a cool problem to begin with. And remember this week, sorry, I didn't even tell you, we're working with adding and subtracting fractions again. So the same as lesson 19, but we're less worried about like how do I show it on a number line in a model. It's more about like finding the answer this time. We're actually solving them, okay? So, blue problem. Lynn, Paco, and Todd share a pack of 12 cards. Lynn gets 4 cards, Paco gets 3 cards, and Todd gets the rest of the cards. What fraction of the pack does Todd get? Okay, so here are the 12 cards, and at first I thought they were Star Wars cards because today when I'm doing this lesson, when I'm recording this, it's May 4th, and that is, some people know it as Star Wars Day because like May 4th, and in Star Wars it's May the Force be with you, so May the Force, May the 4th. Get it? May 4th, May the Force. So anyway, it's Star Wars Day today. And so I saw this at first. I opened up to this page and I was like, oh my God, Star Wars cards. That is so cool. But no, it's just space. Like they're just like planets and like strange space cards. So kind of a bummer, but I mean, it's still cool. Still cool pictures on these cards, especially that one. Looks like the Mars rover or something. Anyway, so these 3 friends are sharing 12 cards. So I'm going to have 3 friends down here. There's Lynn, Paco, and Todd. Okay. So it says Lynn gets 4 cards. So here, we'll just circle in the picture. There are Lynn's cards. Paco gets 3. 1, 2, 3. And then Todd gets the rest. So whatever's left over. Okay. But it doesn't ask how many cards does Todd get. It's what fraction of the pack does Todd get. So I need to know how many cards are there total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They share a pack of 12 cards. So the denominator for all of that, all their fractions, I should have spaced this out more, is 12. Okay, because if it's like a fraction bar or a fraction model, okay? The total number is 12. That's the denominator. So how many out of the 12 does Lynn get? Lynn gets 4. So Lynn gets 4/12 of the pack. Paco gets 3 cards, so that's 3/12 of the pack. And Todd gets whatever's left. Okay, so that would be 1, 2, 3, 4, 5. So Todd gets 5/12. Okay, but I can figure that out by looking at the picture, but I can also add and subtract fractions to figure that out. So I could take Lynn's amount, 4/12, plus Paco's amount, 3/12, and figure out how much do they have together. Okay, so remember, denominator stays the same. You never add the denominator. And 4 plus 3 in the numerator is 7. Okay, so Lynn and Paco together have 7/12 of the pack. If I take the full pack, 12/12, and subtract Lynn and Paco's amount, that's going to tell me how much Todd gets. Okay, so remember, never subtract the denominators. That just stays 12. But you do subtract the numerators. 12 minus 7 equals 5. So there's where I checked my answer. Check. They're the same. 5/12, 5/12. Okay? So we're still just adding and subtracting fractions. This one was a two-part problem, but still just adding and subtracting fractions. And remember, as long as you can add and subtract whole numbers like 4 plus 3 and subtract like 12 minus 7, you can subtract and add fractions, okay? Back page, and we'll answer some questions about that problem. Okay, number 1. Look back, explain how you can find the fraction of the pack that Todd gets. So how did we get our answer? Well, we said Todd gets how many cards? 5 cards. Okay, now explain that. How did we figure that out? We know there are 12 cards in the pack. So the numerator is how many cards he gets, the denominator is the total, but that's just kind of like looking at the picture way, right? We added Lynn and Paco's fraction of the pack. Fractions of the pack to get 7/12, period. Then we subtracted that from 12/12, the full pack, to get 5/12. And that was the answer. Okay, pause if you need to catch up with that. Sorry, the table is shaking. Ollie's like scratching himself right now, so he's shaking the whole desk. Rude. Number 2. Look ahead. In the problem on the previous page, the whole is the pack of the cards. So like the total number of cards, 12/12. Since there are 12 cards in the pack, each card, so one card, represents 1/12 of the whole. Look at the whole shown here. The whole is the pizza. It is a single object. So this whole pizza, that whole pizza is one whole, right? One whole pizza. How many equal parts are shown in the pizza? So total number of parts, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 equal parts. What fraction can you use to describe each piece of pizza? So one piece of this pizza is what fraction? 1/8. Okay. What fraction can you use to describe the whole? So what's my fraction for the entire pizza? 8/8. What fraction can you use to describe the 3 pieces being taken away? So see these 1, 2, 3 pieces right here that are cut and separated? These are the pieces I'm gonna eat. And all 70 of you 4th graders watching this can eat the rest of this. You guys can share, but I'm eating these 3. So my pieces, what's the fraction of that compared to the whole pizza? Okay, well, I'm eating 3 pieces out of 8, 3/8. Okay. All right, reflect down below. How does knowing about equal parts help you add and subtract fractions? Okay, so I can help you with this one because it's not like about your favorite strategy or anything. That's usually what the reflect questions are asking us about. But this one's just asking us, how does knowing about equal parts, like on the pizza, help us add and subtract fractions? So you're gonna be overthinking it. So let me help you out. They just want to hear about how adding fractions is about joining equal parts together, equal parts of the whole. And subtracting fractions is taking away equal parts of the whole, okay? So, adding fractions is joining, that's an ing. I tried to do a G right there. Joining equal parts of the whole. Okay, and subtracting fractions is taking away equal parts. That's it. Adding fractions is joining, subtracting fractions is taking away. Same as whole numbers. This is just equal parts of the whole thing. Okay? So pause it there if you need to. I'm moving on to practice page. Okay, so in the middle of our bubble is just the word fraction. Interesting. Thought it would be a little more difficult than that, but fraction. What is a fraction? What is it? What's a fraction? It's kind of hard to describe what a fraction is, right? Like without giving an example of one. How do you just use words to describe a fraction? That's difficult. So it's a number that names equal parts of a whole. Ta-da! Okay, what I know about it. What do you know about fractions? Tell me in this box here. Maybe you know what that part's called and what that part's called, and I gave you a hint because I used letters for those. So maybe you know what each of those parts is called. And maybe you know what each part means. If you know what it's called, maybe you know, like, how do you know what number to put here? How do you know what number to put here on the bottom? Okay, that would be a good thing to put in this box. And examples. Okay, well, examples, you could just like come up with any numbers for your fractions as examples down here, right? Whatever you want. Any examples. You could also draw a fraction bar model. Whatever fraction you'd like. Okay, so that demonstrates a fraction. I could also do a number line to demonstrate fractions. 0, 1/4, 2/4, 3/4, 1. Because 1 is 4/4. Okay, so whatever you'd like to do for your examples, totally fine. Number 2, does the model below show eighths? Why or why not? That's tricky. Okay, so does this model show eighths? Well, technically, aren't they all labeled eighths? Yeah, they're all labeled eighths, but what's wrong with it? Something's wrong here. If you need to get out a ruler to check that something is wrong here, you can. But you should notice that, well, this little eighth down here is not the same size as this eighth. So how can they be different sizes if they're both 1/8? That's impossible, okay? So no, this does not show eighths because they're not equal parts. No. Because they are not equal parts. Okay, in order for that to show eighths, yeah, they gotta be labeled eighths, but they all have to be the same size. If this is 1/8 and this is 1/8, but they're different sizes, that doesn't make any sense. Okay? So, 1 star if you said something about equal parts. Back page, and then we're done. Fast lesson. Oh my goodness. So cute. Let me zoom out a little so you can see all of them. Okay. Step 1, pick your favorite animal. Oh my goodness, I love foxes. I love deer. I mean, cougars was my college mascot, so I feel like I have to pick them. But manatees are so funny. These little birds. I think these are called spoonbills because of their bill, their beak is like spoon-shaped. I don't know, guys. That's, oh my gosh, this is the hardest problem in this math workbook, picking my favorite animal. I don't know. I give up. Can't do math anymore. But I'll do my best. Okay. Number 3. Maria, John, and Kara share a set of 10 animal stickers. Maria gets 2 stickers, John gets 4 stickers, and Kara gets the rest of the stickers. What fraction of the stickers does Kara get? Okay, so putting my issues aside, Maria gets how many stickers? Okay, so, or what fraction of stickers does Maria get? So it says Maria gets 2 stickers, so she gets 2 out of the total 10. Okay, so Maria gets 2/10ths of the stickers. John gets 4 stickers, so that would be 4 out of the 10. 4/10ths of the stickers are John's. So, get a different pen. These 2 are Maria's. These 4 are John's. So those are his fraction. That's his fraction of the pack. And then Kara gets the rest. Okay, so I can easily see like 1, 2, 3, 4. Well, Kara gets 4/10ths of the pack. But if I wanted to check my work, I could do 2/10ths plus 4/10ths equals 6/10ths because I don't change my denominator, and 2 plus 4 equals 6. Now the whole pack is 10/10ths, and I'm going to subtract the 6/10ths that are Maria and John's total, and I'm left with 4/10ths. 4/10ths right here for Kara. So solution, Kara gets 4/10ths of the stickers. She gets the same amount as John. So if you did 4/10ths, you get a star. If you showed your work, you get a star. And technically what I just did right here is the check your answer part. Okay, so arrow to there. And another star because you did it already. Ta-da! First lesson done. First session, I guess. Next up is session 2. Have a good day, guys.